Okay, quiet. All right, I'll try and wake you up. No, I won't. All right. Okay, so I'm back to do a talk and sort of demo of some of the tools that we use for building progressive web apps. Some things that you can use to understand how your apps work and how you can make your web experiences better. So one thing I will say about this demo before I go on, I am going to cheat a little bit today, and I will apologize. I'm not going to do it live because the internet connection here is a little bit slow, and for me to do this live, it just wouldn't work. So I took screenshots and video last night, so I'll show you essentially what I would do. But I want to take you on a journey. I want to sort of take you through how you can use some of these tools to make your experience, your site better. As developers, it's important for us to have insight into areas that we can improve and areas that we can make things work better and make things more awesome for our users. So in that spirit, let's take a little journey on a website and transform an existing single-page app from just a pretty meh single-page app to a progressive web app. So our starting point is this app here that you'll see on the right. And it uses the iFixit API. iFixit is, how many people are familiar with iFixit? Okay, so a few. iFixit is a site that they do teardowns and take products apart and show you how to fix it yourself. So it's a pretty neat site in terms of some of the stuff that they have, but they also have an API so that you can write your own front end. So this site in its current implementation, and what I'm going to show you in 1 second, uses client-side rendering. So it goes, gets the data, and renders on the client. And it uses React to do this. Now, the concepts that I'm going to talk about today, you can use any framework. In fact, I'm using React because it was just an experiment. I don't really know React at all. We're going to have people come in and talk about Angular. These tests that I'm going to show you how to do, the work that I'm going to show, applies exactly the same, no matter what browser you're using or what library you're using. So I'm going to open it up and have a look at what the experience looks like in Chrome. So I'll open it up. You know, it looks like a standard web app, right? It's got a nice little address bar across the top, some images, and I can click on any of these things. So, all right, Chrome looks great. And Firefox, because it's always important for us to be testing our apps in all of the different browsers that our users are using. So look at your analytics. What browsers are users coming in on? And making sure that you're testing on those browsers. So Firefox, yep, looks great, awesome, yay, really happy. But Safari, I've made a little bit of a change because I think it's always important to test in one browser where you've turned off JavaScript. And, wah wah, right? That's bad. It's not that Safari is bad. We have turned off JavaScript. And we're client-side rendering. Client-side rendering plus no JavaScript means no page, right? So in this particular instance, this sucks. Our users who don't have JavaScript are kind of stuck. So now that we have a feel for what the app does and what it looks like, let's try and figure out how we can improve this implementation. And we're going to use a tool called Lighthouse. Lighthouse is a tool that is built by a number of engineers at Google and automates a whole suite of diagnostic tests that cover areas important to progressive web apps. Now, it's available as a Chrome extension, so you can get it as a Chrome extension. And it's available as a couple other things, but first, let's use Lighthouse to establish a baseline to see how it's going to work. I meant to mention this earlier. It also works as a node module, so you can test your app as you're running. You don't always have to use it as a Chrome extension. You can put this into maybe your build process to understand, hey, how are things working? And get your score there. So before we jump in and see what our Lighthouse score looks like on this test, Lighthouse is a process. It is not a destination, right? It's to help us identify areas that we can improve, but it's not the thing that we're going to say, I want to get 100 out of 100. It's kind of nice, but that's not the point. The point is for us to take our step up from wherever we are and build it better. Ultimately, the experience that your web app provides is for your entire user community, and that's what matters most, right? Is building a great experience. In addition to testing across all devices, like I said, it's important to test across different browsers and OSs. You can't just use Lighthouse and be like, woohoo, done. Don't do that. That's bad. Test across all devices and browsers and use different tools to help you understand. So with that, let's take a look and see how we do. Whoa. 20 out of 100. Now, I said that getting 100 was not your goal, but 20 sucks. We want a better number than 20. So let's take a look at why we have a score of 20. So first thing you'll notice is it's checking to see if there's an offline experience. So app can load in an offline or flaky connections. So it's looking for a service worker. It's looking to see that when it's offline, that there's a 200 response. So, okay, there's two things that we know we can fix today. We've learned how to do that, right? We can implement a service worker and we can fix that one. Okay, good. Performance is fast. First meaningful paint, it took almost 4 seconds until the first meaningful paint today, or for me to run this last night. That's a lot of time, right? So we had to download not only the HTML, but then we had to download the JavaScript, we had to parse the JavaScript, we had to execute the JavaScript, and then we went, oh right, I guess I need some data. So we went and got the data. We downloaded the data. And then we could render something. That's client-side rendering. If we switch to server-side rendering, where we just make the request and it's like, hey, here's everything, that number is going to come down. Perceptual speed index, okay, that's kind of high. Time to interactive is almost just over 7 seconds. That's a lot, that's slow. So I think we can do a bunch of things to improve our performance. The next thing it's going to look at is the site is progressively enhanced. So there's one key test for this. Page contains some content when scripts are not available. We saw that. Wah, wah, right? That's another easy one for us to fix by adding some server-side rendering. So no content when JavaScript is unavailable. Now, your network connection is not secure, or your network connection is secure. Now, remember we talked earlier, service workers require HTTPS. Now, I'm running this on my local machine, so I don't really need that right now. So we're just going to ignore that one. That one's okay to fail when you're doing local development. So then the next thing it asks is the user can be prompted to add to the home screen. So it looks for a service worker, a manifest. The manifest contains the start URL, an icon is listed in the manifest, and a short name. So it looks for the things that Chrome needs to prompt. And then finally, installed web app can be launched from the splash screen. So it's checking for a bunch of things here. So this is another easy one for us to fix. Sam showed us earlier how we can go add that manifest, and we're going to go add a manifest today. And then address bar matches brand colors. The design is mobile friendly. Well, it is mobile friendly, so at least we got that one going for us. It checks for a number of best practices, looking for things like offline features, looking for performance with HTTP2. It looks for accessibility and a number of things like that. And then finally, the performance metrics. So it gives us a lot of data for us to be able to go, how's our site doing? Is it any good? So the first thing that I want to do is I want to go and add server-side rendering to my app. I want to take this app that we've built already and is doing all client-side. And remember, this is client-side with React. So that means the browser gets a fully populated page in the initial HTTP response when I do server-side, rather than relying on multiple requests to get content on the screen. Equally important, it means that our web app will work in browsers where JavaScript is disabled, in that Safari example that I talked about earlier. Now, not every web app will be able to run with full fidelity with JavaScript disabled, but in our case, that's okay. Users are going to click on something and see something else. It works. So it's fairly straightforward to add in server-side rendering to our React app using universal JavaScript that we can share between our client and our server. So we're going to use Express in Node as our web server because it plays nicely with the React router. While we're talking about React, like I said earlier, other frameworks like Angular, Ember have their own solutions for server-side rendering. So this works for them as well. I'm just using this as the specific example today. So you can see here, I've added I've got a gulp file as part of my build process, and I've added a new gulp serve task, which is going to serve my app, right? It's going to spin up my Node web server. And I've added a web server to my build. So this is where we're actually going to build the server rendered version of the page. And down here I've got this really important bit. This is where we're actually going to use React to render the page on the server. So now when I make a request for that initial page, I get the content already rendered. I need to make one other change to my page. I need to change my index.html because I need to actually make it templated so that I can start to render the content server-side. And all I do is have this fairly simple HTML body, right? And I've got React HTML as my template in there. So I'm just going to shove everything in. All right. So now that we've got server-side templating set up, let's run the Lighthouse tests again and confirm that it worked. So see how it did. And let's also have a look at it in Safari and see if it works there, because it should work now, right? Okay, so Chrome, boom, 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 starts loading. Spin, spin, spin. It's taking a little bit of time, but it works, right? Notice how this time, one of the big differences was that images started populating in almost right away, right? Whereas last time, all of a sudden, well, we saw the boxes, and then a few seconds later, we got the images. So the perceived performance of this was actually much faster. It took a little bit extra time at the very beginning to get that content down, but as a user, I feel like it rendered faster. All right, Safari. Let's see how this one goes. Now remember, this didn't work at all last time. And there we go. So in Safari, Now we get all of our images. It works. It behaves as we would expect it to work in Safari. So that's awesome. We've got a little bit of a step forward. Let's run Lighthouse. So this is what Lighthouse looks like when you run it. I've got it up as the Chrome extension up there, so I just went and I hit the button and it says, okay, it's gonna go and run. And it does a bunch of different things. It requests the page in debugging mode, it requests the page in different screen sizes, it goes and runs and requests web SQL data, it does all kinds of just crazy things. And then it comes back and it gives us this result. All right, we went from 22 to 37. Oh, okay, all right, I'll take that. Still not a passing grade, but we've gone up. So now there's a couple of things that have happened to make our experience better. All right, so app can load in Flaky. We didn't do anything around that. But let's look at performance. Remember before our performance was kind of embarrassing? So now our first meaningful paint happens at 1.4 seconds. We were, what, 6 or 7 seconds last time? Time to interactive went from 7 seconds, it was like 7,065 milliseconds, to 2,100 milliseconds. Our performance significantly increased here. So that's a big part of why we got that number bump. The other one is the site is progressively enhanced, right? The page now has content if I don't have JavaScript installed. So I've got a good piece there. Now, the rest of these things haven't really changed, right? We haven't made any big changes here, so I wouldn't expect any of these to change. Okay, design is still mobile friendly, woohoo. Our performance, all right, we're in a better place overall. Now, we could still do better, and we're going to do better. So, next, let's add a service worker. You heard me talk today, earlier, about how you can build your own service worker, but, you know, let's do it. So one thing to remember, service workers are a progressive enhancement. Not all browsers are going to support that, but that's okay. Because for browsers that don't support it, okay, they're not going to get that little boost, but for browsers that do, they will. So even on browsers that do support service workers, that service worker experience isn't going to do anything for the first load. So it's just that one little bit to remember. Now, our app is built using an app shell model. And the app shell model, think of an app shell model in a similar way as a native app would work, right? Where you're going to store all of the key resources needed for your app that aren't going to change. Everything but the data on the device. And then you'll go get the data from the network. That way you don't have to transfer everything. You only have to transfer a little bit each time. That means that we can cache the app shell locally, and we can use runtime caching strategies for our data so that we can make requests for dynamic content. All right, now one of the most important things to understand when you're building any kind of web app and want to use a service worker and want to start to make it better is understanding what network requests get made and how and what you need to do with those. And the dev tools are a really important place to have a look at that. So we need to configure, we're going to use SW Precache and SW Toolbox. Those are two libraries I talked about earlier today. We need to go and use those to have a look and see what's going on. Use those to see what's going on. So let's have a look at how I went from step 2, where we added server-side rendering, to go and add our service worker. So the first thing I did was I added to my Gulp build task SW Precache. And SW Precache is that thing that's going to help us pre-cache our key pieces. Then I've added a Gulp task called Generate Service Worker. Really creative name, I know. So Generate Service Worker is going to go and build our service worker for us. And there's a couple of things it does. It does arc static files, it does some dynamic files, and it does some other various runtime caching strategies. So the key thing here is we've said, hey, I want to cache my app shell, I want to cache my data, and we're going to go from there. Then we need to make one minor change to our index.html. We need to register our service worker, right? So if service worker in Navigator, register service worker. Okay, so now that we have our service worker in place, let's run the Lighthouse tests again and see how this works, right? And see how it goes. So it goes, it loads the page, renders the trace, loading page again, rendering, loading, rendering, wee. So 20, 37, 52. So just by adding a service worker, we've taken that number and we've bumped it up a good bit. So there's a couple of key things that have changed here. So first, here's this big one, right? As the service worker, app can load in flaky and offline connections. That's kind of awesome. Okay, now performance, first meaningful paint, awesome. Time to interactive, those are all great. Now, it's important to actually make sure that we are serving our app from the service worker, right? So you can use the DevTools to do that. And the way that I did that is I opened up the DevTools, and I went over to the network, and I refreshed the page. So when I refresh the page, I get the information in the network panel. So here's the file that was requested. The HTTP response code, so 200, awesome, okay. Actually, I guess it's not awesome, it's just okay. What kind of file it was, who made the request, and then here, the size of the file. Now, look at all these nice, beautiful brackets that say from service worker. That's telling us that that network request didn't go over the network. We just pulled it off our local device. So almost everything came from our service worker. That's exactly what we want, right? So when you're testing your site and understanding, okay, where are things coming from? Is this going to work offline? Is this going to work if I don't have anything? Open up your DevTools and have a look. Where is everything being served from? And at the same time, also, one thing to notice, look at these response times. 0 milliseconds, 1 millisecond, 0, 1, 1. You know, our worst one is like 17 milliseconds. That's kind of awesome, right? When you think about performance, to be able to get something that fast, there's no way you could get that across the network in anywhere near that amount of time. Now, while we're in the DevTools, I also want to point out this application panel. This is the one that I talked about a little bit earlier and said is probably going to be one of your best friends. The application panel is the central place for debugging everything to do with service workers or progressive web apps. All the stuff that you need to deal with is in here. We can confirm our new service worker is running. So serviceworker.js, right, is there, and it tells us when it was received, so this is an older screenshot. But it tells us, here's this really big one. Service worker status 0, activated and is running, and there are no errors. That's a good sign. There's another really good one to keep an eye on when you're in the service worker panel, if you're looking at your service workers. If you refresh the page, and I'll show this in one sec, if you want to see if the service worker has updated, look at this number here. That number tells you what the ID of the service worker is. So if I reload the page right now, and the service worker hasn't changed, that number will stay the same. If I reload the page, and I get a new service worker, and it takes control right away, that number will get bumped up. So you can always tell, oh, hey, hang on, I updated my service worker, but the old one is still running because the number hasn't changed. That's just one of those really helpful little bits that I like. So there's a couple of other things that you can do in here. You can go and you can say, if you check that checkbox, Chrome will put the browser into offline mode and won't send any requests to the network. Quick, easy way to test offline. You don't have to shut down your server or anything like that. You can just say, hey, offline. Update on reload is another helpful one, and I recommend checking this checkbox when you're doing your development, because it just always says, hey, go check for a new service worker always, and if there is a new one, just reload, just start using this right away. And it always puts the code into, puts the service worker in control right away. So I use that one a lot. And finally, bypass for network. This allows us to skip the service worker's fetch handler and go straight to the network. So, okay, skip the service worker fetch. Doesn't that kind of defeat the purpose of the service worker? Yeah, it does. But the good thing here is, say for example, you're testing a page and you change the color. You change something in CSS and the color's not changing. And you can't figure out why it's not changing. You're like, I changed that. You're just banging your head against the desk. Go check that bypass for network and try refreshing. If the color changes, it means that your service worker isn't updated. It means that you're still serving stuff from the cache. So bypass for network just skips the service worker cache. Now, let's take a look at a couple of other little things that we can do to bump that number up a little bit more. Sam talked earlier about using the manifest to tell the browser how we want to be shown on the user's home screen and add ourselves to the home screen. So let's go add the appropriate metadata. Now, we're going to use the manifest, right? Because that works for Chrome, that works for Firefox, it works for Opera, it'll work for Edge, I believe soon if it doesn't already, but it doesn't work for one other browser that I bet a bunch of you have on your phones. Yeah. So if you use Safari, Safari doesn't recognize or doesn't read the manifest. So for that, we need to add a bunch of meta tags. So let's have a look at what we need to do for that. So you saw this with Sam earlier. This is the manifest. This is one for the Washington Post. We're going to add something very similar. And we're going to do this. So I've added an image. Now, the image that I've added, I've picked a 144 by 144 pixel icon. If you're only going to do one icon, I would recommend that one or something bigger. All right? Now, if you're like me, you don't start twitching when you see icons that have been rescaled and are not pixel perfect. Some people who are very designer smart and they all look really fashionable and really cool and wear turtlenecks and that kind of thing will supply lots of different icon sizes and they will hand tweak each one. Awesome. Go for it. I'm too lazy. So one icon at 144. I've added a manifest. So it's got the name, the short name, it's got that one icon, the start URL. It says display standalone so that the app always starts without the address bar. We set the background color and a theme color. All right, so now we've got our manifest. There's one other thing that we need to do. We need to update our index.html file. And we need to add the Apple meta tags, right? So we need to do the icon, the Apple Touch icon. We need to do the Apple Mobile Web App Capable. I always hate typing that one in. It's so long and annoying. But Apple Mobile Web App Capable, yes. And then we need to tell the browser about our manifest file. So that's the one right there in the middle. Meta name, link rel manifest, and point to our manifest. All right? So we've added our meta tags. Let's give it a shot. Let's see how it works. So go load it in Lighthouse. Goes, it does its thing. Waiting for page, waiting for the onload event, checking HTTPS and viewport, theme color and manifest and all that kind of fun stuff. Normally, if you're doing this on a good fast network connection, it'll only take about 15 seconds to run. If you were doing it like me at the hotel I'm staying at, which has not very fast wireless or very fast internet, it takes, 30, 45 seconds. So, all right, we're almost done here. Retrieving web SQL, well, there's really nothing. All right, 78. That's not bad. We took our number from 20 to, 32, 30, or 20, from somewhere in the 20s to somewhere in the 30s to somewhere in the 50s to somewhere in the 70s. That's a little bit better. All right, so we took that number up pretty significantly by just adding 4 things. So the key thing that we've added here is we now have that registered service worker. So we've got that 1 bit. So our URL responds with a service worker, and we get a 200 OK when the app isn't working. Then there's one other panel that I like within the application panel. And that's a couple other things. Looking at this manifest tab, we can actually see what's going on in our manifest. So we can understand, oh, hey, we've got these things. So you can see the name and the short name. So we can make sure that the manifest is being loaded properly. We can see the start URL, the theme color, the background color, the orientation display, and all of the icons. Now, one of the things I've caught some mistakes that I've seen in some of my own apps, I'll always scroll down and look at all the icons, because sometimes I've had a typo in my icon list, and I'll get a broken image. So just making sure that all the icons get loaded, making sure that you've got everything there. One of the other things you can do is hit that add to home screen. And that will simulate adding it to the home screen. So you can see how that process will work, because there's a couple APIs you can throw in for there. I can see the service worker stuff, so great, awesome. We can see that I took this at 9:34 last night. I was working on this. You can see that number is up to 12. I can dig into the cache. I can see what's going on and what's been cached. So in this particular case, remember I talked about cache names? I've got 3 different cache names going, 3 different caches. SW precache v2 app something, $, toolbox cache something, and image cache HTTP. And so you can see all of the stuff that's in my cache. I can go, yep, all those are looking good, sweet. So those tools are really useful in order to do this. Now, I'm gonna cheat. I said I wasn't gonna do anything live, and I'm not really gonna do anything live, but I'm gonna do something live. All right, well, I want my screen back, please. Okay. All right. So, notice, I want to point out one thing. Network is totally off. There's nothing plugged in here. But if I go, you can see all the fun places I've gone. Local host 8084, which is where I had my site. It helps if I'm doing it in the right browser, or in the right person. There we go, person 1. Let's try this. All right, 8084. So no network connection. Everything is there and cached. And in fact, I can even go in and see some of these things that I clicked on earlier. So I've got that full experience that works offline, nice and fast, nice and easy, works really well. So let me pop back to my slides. So as you think about what you're building and how you're going through all of your products and building user experiences, think about how you can take tools like this to say, how do I make my app better? What are some easy things that I can do to sort of take my app to the next step? You don't always have to start from the beginning. You don't always have to do anything crazy. Just taking little steps is a really important process. So I hope I've inspired you a little bit to follow our lead, to take some of these things back to your team, how you can use Lighthouse as a way to really understand what's going on, to build experiences that delight your users. But don't forget, progressive, fast, delightful UX is your goal. Building progressive web apps that are reliable, fast, and engaging is fun, I think, and helps us make the web a little bit better. So before we go, I'll point out a couple of links. The sample code that I showed you is there at this link. It's up on GitHub, so you can download that. You can actually walk through all the steps. You can get Lighthouse. Lighthouse is up on GitHub as well. You can either download the source and go and compile it yourself and do some of the fun, crazy stuff. Look at how some of the tools or the tests are written. You can take a look at a couple of other things, but the other one that we have, and I really would recommend you go check this out, is the code labs that we have on building progressive web apps. There's a couple of them, there's 3 of them that I think are really fantastic. They're up on developers.google.cn/web/fundamentals/something code labs/go from there. Just click that link. Well, don't click that link because that's not going to do anything. But type that link into your browser. The 3 that are there, building progressive web apps from the ground up, debugging service workers, which will walk you through all of that panel really well. And the 3rd one is adding push messages to your progressive web app so you can see how that works. So with that, I want to say thank you very much. I've had a great time today. I hope you've learned something as well. I will open it up to questions now. All right, you had questions all day and now you have no questions? Okay, I'm going to go sulk in the corner. Oh, yes.
Hello. I want to ask if there are many websites they use service workers. So in the browser, the service workers will store many cache. So the cache is, I want to ask is their cache is limitation. So when their cache is full, so how to the browser to manage it?
Okay, awesome. Great question. So are there many sites using service workers today? And then at some point, as more sites start using the cache is going to get more and more full. And at some point, your phone, your laptop might run out of space. And that could be a challenge, right? So there is one place that I would recommend you go if you've got Chrome installed. Go to Chrome, in the address bar, type Chrome://service worker, one word, -internals. That will actually show you all of the service workers that are installed on your device, on your computer. I'm not sure I'm going to be brave. I'm going to try. Let me just see what it looks like on... can we switch to my laptop again? Okay. Please don't make fun of the websites that I visit, okay? That's all I ask. This is my personal computer, this is my personal profile. Service worker internals. Okay. So you can actually see all the sites that I've been to that have service workers. Okay, so I haven't been to many pages. On my real computer that I have at home, this goes much, much longer. So the question about getting, at some point you might start filling out. There are two things that are going to happen. One, there is a new API called persistent storage that lets you as the web app developer say, I want persistent storage. I want to be able to keep this on the user's device no matter what for all time until the user makes the explicit decision to blow it away. That's coming. Actually, that's already landed in Chrome. It's coming to other browsers. For other things, what's going to happen is the browser is going to blow it away as it starts to need more space using a least recently used algorithm, right? So it's going to look at that one website that you went to 12 months ago and haven't been back to since, and they're taking up 10 megabytes, and well, you haven't been there, so you're probably not going back. So it's going to work through things that way. Now, it's also not going to go take up all your hard drive. Chrome is going to take care of being a responsible citizen. As developers, I would ask you, until we get more of the persistent storage stuff, to be responsible developers. Don't necessarily download your entire website or, gigabytes worth of stuff, because one, it will take forever to install, and two, if the user's not going to use it, don't pull it down. Next question? I can sing. I can't sing. It's not worth it. Ask questions or I'm going to start singing. Okay, well then I'm just going to go in the corner and sulk then. So thank you all very much. It's been wonderful. I hope you enjoyed this. Thank you.